been done perfectly, the half of the work will be done in that, right? So only we will know before writing the program, flowchart is important. If you know to draw the flowchart or define your problem in the flowchart properly, half of the work will be done. And the same for DFD also. And here the modeling approaches. Here we'll see about ER diagrams, everything. So the approach should be a genuine one of how we are going to design the model. Okay. For designing the model, you have to analyze the problem then. Okay, that means, see, suppose if a customer is coming to the shop and he's asking for something, first the person in the shop or person in the company should analyze what is the requirement of that particular person. First, he must understand in the sense he must analyze what is the exact need of the person. And then after analyzing this problem, he should be able to design the problem. Okay, after analysis and design has been done, execution is very simple. Implementation is very simple. Like that, the analysis modeling is an important part here. The elements of analysis model has to achieve three objectives. That is, yes, first, to describe what the customer requires. Yes, as I told, first he must know to understand what is the requirement of the customer, the first one. Second one is to establish a basis for the creation of the software design. That is, establish a basis. That means how you are getting the, see, what is the, how to tell, how much you can able to understand, how much you can able to understand the requirements of the customer. In that case, you have to design the requirement also. I must be able to see if I am in the analysis section, and if some person is coming and coming for a project or to do some work, I must first understand the requirement. After understanding the requirement, I'm not the only person who will be doing the entire process for him. I will be having one team to do. For to explain to the team, I must not I should not ask the customer to again keep on explaining the thing each and every day or once in a week. I cannot call the customer to explain. The only thing, the person who received all information from the customer, he is responsible for that team to explain the problem clearly to the team, right? So how much clear he is explaining, only the output going to be. So on the basis of the requirement, he has to create a software design. The third one is to define a set of requirements that can be validated once the software is built. Okay, the set of requirements has been done and it has to be validated. Whether it is achievable or non-achievable, each and everything the team has to decide. Okay, these are the three primary objectives of analysis model. See, for to do that, how the process has been done. See, in this diagram, see how the data dictionary is here. This is ER diagrams. This is ER diagrams. Here DFD. According to the requirement, which STD, these diagrams will be helpful to frame the structure. Now, whatever things for if the thing is considered about the process, we will be using DFD. If it is in the control part, we will be using this state translation diagrams. If it is simply data object description, then we will be using ER diagrams. Okay, according to that, we have to choose the type of diagram. Type of diagram means it will be easy for you to understand the problem only through the visual, through the diagrammatic way, on the visualizing way, you can able to understand the problem clearly. Okay, first we'll see about DFD. These are all the simple things, right? For each DFD for the PG students was not very good, I think. DFD serves two purposes. That is, first is to provide an indication of how data are transformed as they move through the system. It provides a simple indication of how data has been done, how data has been transferred from start to end, how it is moving, and to depict the functions. And depict the functions is whether it is reading the value or getting the value, printing the value, all the things the sort of some depiction we'll be using. Sub functions, all the things we can able to describe in the DFD itself, right? And that transform the data flow. It should be in the it should be clearly understandable. See, you can be a technical person. You can understand the problem better more than DFD. A technical person can understand the problem. If a boss sitting there will not be very technically sound, but he has the management capability. So for him to understand, the DFD has to be in such a way he can understand how the flow is going, how the process is going, in which process they are. Like that, they have to understand properly. Okay, next is data modeling concepts. Data modeling. The concepts behind that are data objects, attributes, relationships. Okay. Data objects, attributes, and relationships. Here the full stop has to come here. Data objects, attributes, relationships. The data model consists of three interrelated pieces of information: data objects, the attributes, and how we are going to describe the data object. Okay, see, the three parts they are explaining in three ways: data objects, attributes, and relationships. The data model, we are making this in the three pieces of information: data objects, attributes, and how we are going to tell the relationship, the same thing they're telling here. Okay, we'll see one by one clearly. You leave all these things, we'll see one by one. Data objects, maybe data objects here. Okay, you take these three alone here, leave all this. Again, the same thing they're doing. Data objects, attributes, and relationships. Data objects. The data object is a representation of almost any composite information that must be understood by the software. Data object means it's a represent of any composite information. If I am giving in a raw way, what is the expectation or the requirement of the customer, it has to be put it in the way finding the data objects in it, and it is a representation of any composite information. That composite information should be understood by the software which are going to use. The data object can be an external entity, that is anything that produces or consumes information. Data objects means it should produce. It may be right a report or a payroll processing, like that. It can be, and it has to the data object can be an external entity or an external entity of which I can use or which I can produce. Okay, these things we'll call as a data objects here, and this data objects the data objects are these things, and attributes again the same thing. Attributes, once a data object has been set, the attributes, again the parts which are using inside the data object, we'll call that as an attributes. According to the attributes only we can able to set the program. Attributes define the properties of data object. Yes, it defines. See, suppose my data object is mark sheet processing, receiving, produce mark sheet. Okay, in producing mark sheet, what can be the attributes? Only the register name, student name, register name, date of birth of the student. These are all the attributes only I can have inside the data object mark sheet. I cannot have employee ID or some other thing. Okay, so the relevant to the data object will be the attributes. So it has to define the properties of the data object and take one or more different characteristics. That is, it has to be used. It can be used to name the instance. As I told, if it is mark sheet, it should define the instance, the name and instance of the data object, and describe the instance for what purpose it is doing, for exam preparation or for whatever enrollment preparation, for the instance which we are using these attributes, and make a reference to another instance in another table. Okay, these are the basic things for defining the attributes. For defining the data object, the attributes has been set like this. Next is relationship. Data objects is there, then attributes is very important part there, and more than that, relationship is very important. Data objects are connected to one another in different ways. Here, for example, we are taking bookstore, two data objects, book and bookstore. For book, we can have certain attributes. For bookstore, we can have certain attributes. And here we are going to see about two data objects, book and bookstore, and how we are framing the relationship is bookstore will order books. Bookstore can display the books. Bookstore, they can stack or stock the books. They can order the books, they can stock, and then bookstore will keep the will be selling the books, or it will keep to only the purpose of reading, and the bookstore is kept only for the library purpose, like that. Only reference is allowed, like that the process will be done, and bookstore returns books. Okay, these are certain relationships. We can extend a lot of relations from the data objects. According to our example mark sheet, we can have two data objects, student and student data, like that also you can have. Student data consists of details of student. Student must have a student data. From the student data, a student can be identified. Like that, from the student data, the student will be okay, identified, or he can he can be distributed. The register number will be set like this. The data store has to be there. The student data will be there. So, like that, the data objects will be set, and in that data attributes will be there, and relationships will be set like this. See here, this is one important diagram, ER diagram. Entity relationship model. A simple model we'll see in detail next class. Entity relationship model means we will take the same example of what we have seen: the student ID, student, and age. This will come under one data object. Course ID. This will come under one data object, and here student age, we'll call that as an attributes here, and here the course ID. Only here we are the information will not be about the students, only the information about the course, which year of regulation, how many credits it need, how many units, all these things will be in the course ID. Okay, a relationship has to be set for the student to pick up the course. Okay, like here, this is what we call as an entity, different entities, and how the relationship has been set. And next is cardinality and modality. The elements of data modeling. What we saw is data objects, data objects, attributes, and relationships, right? These three elements provide basis for understanding the information domain of the problem. Once, once able to bring out the data objects, able to identify the attributes, and able to set relationships, these three basic elements will provide or it will set a route or set a path for understanding the information domain of the problem. However, additional information related to these basic elements must also be understood. These basic elements are these three, and what is the additional information? Cardinality and modality. Cardinality means the data model must be capable of representing number of occurrences of objects. A data model must be capable of representing the number of who is talking. Please mute. Manikandan. Data model must be capable of representing the number of occurrences of objects. Here we just said what are the data objects. This cardinality additional information will be dealing how many times my object has to occur here in the given relationship. This is about cardinality. Modality means relationship is zero if there is no explicit need of, that is we are setting some model. Okay, this is the way the thing should be processed. Like that, we are setting one model. That one we are calling as a modality. If the modality of the relationship is zero, if there is no explicit need for relationship to occur. For my data objects, I don't need any relationship. Only attribute setting is enough means I will set that model as a zero. Okay, if modality I am setting as 1, if an occurrence of relationship is mandatory. For designing a problem for student and course, two things are there. If I am setting this to 0, I will be getting only the information about a single data object. And here the relationship is not mandatory. If I select the modality as 1, whether you have or not, you have to set the relationship where the relationship part is the occurrence of relationship is mandatory. Okay, this is called modality. For to process this properly, in the simple words, we are telling data objects, attributes, relationships, all these things, and along with that, cardinality and modality are there. For to do in a detailed way, in more detailed way, we are narrow downing our process and we are making the diagrams, for making the relationships in a better way, we are framing a diagram called entity relationship diagram. Entity or relationship diagram. Here, the object or relationship pair is the cornerstone of any model. Object or how the thing is related, it is both object and relationship, is the cornerstone of any data model. These pairs can be represented graphically using the diagram which was proposed by Peter Chen, is called entity relationship diagram, ERD. He proposed this diagram for the design of relational database systems. Relational database system means RDBMS. Relational, for the design of RDBMS, he proposed, and the basic diagram or a core design has been set by this person, and further it was extended. RD we know only about DBMS initially. Then a thing we found is relational database management system. For this thing has to be done. That is for a DBMS concept means we have to use one front end tool and back end tool. All these things has to be there. And from here, for to frame this, we are using ERP. Okay, and from this diagram, lot of persons has extended the thing. The set of primary components that are identified for ERT are data objects again, attributes again, relationships again, and the important inclusion here is type indicators. And the primary purpose of ERT is to represent data objects and their relationships. Actually, also in the initially also we have done only for making the relationship, but even detail this entity ER diagrams helps us to make the data objects, attributes, and relationships in a further detailed way using type indicators. For simply entity, they are using this rectangle. Okay. For attribute, they are using oval, flat oval. For relationship, they are using diamond. Again, if the entity is very weak, it is denoted by double rectangle. Multi-valued attribute, it is in flat oval twice, and weak relationship, flat diamond. Sorry, a diamond twice here. Manikandan, Manikandan. Okay, okay. The basic symbols which are using for entity relationships are these three things, and for differentiate little bit clear and clearer, the entity weak entity, multi-valued attribute, and weak relationship, the same symbol with the different formula. And the relationship is a very important here, important one they told, and object relationship and type indicators. How we are defining a simple diagram, but how we are indicating in a further descriptive way. See here, the employee is here, is issued ID card for one employee, one ID card. This is one-to-one relationship. And see here, student is here, courses is here. This one, student can be of one, but options are lot of courses, right? So we can call this as one-to-many relationship. And again, I can use the student as a data object. And how many? See, test is another attribute. And here, one student cannot many students are one student, one test is okay, but the same thing can be done in many students. test. Can take test. Many students can take 5 subjects can be there like that. So many students can take test and it can be framed as many tests like basic diagram one-to-one relationship, one-to-many relationship, many-to-many relationship, and another one relationship with this indicator is like this. Many to one is also another relationship. Okay.
இந்த இடத்துல போய் பாரு, இங்கதான் இப்போ இததான் நான் கால் பண்றேன் அப்படின்னு தெளிவா சொன்னானா அதாவது அந்த மெத்தடை எக்ஸிக்யூட் பண்ண முடியும்.
Okay, I'll stop with this slide today. Okay. This is again a diagram for showing weak relationship that ATM transactions. I am denoting here with weak relation. Next is elements of analysis model. We'll see in the next class Monday. I think all given your register number in the chat box. You don't know which section you belong to, no? Section. So shall I download? Want me to wait for some other time? Everyone give eventually, and the first number is giving now only. Those who given the register number, you can leave the class. Thank you.